in terms of expectations for when your exam is, which is next class. We're going to do some of the review today, but here's the main things that you need to make sure that you know. When you come in, there's a calculator section and a calculator free. The calculator free section, I can assure you, is not asking you to do profoundly difficult math at all. It's designed to be done without the calculator. All in one day, so we'll let you know about the halfway point. And at that halfway point, you're free to take as much time on whichever section as you want, but don't get stuck on a question. The test is designed to be finished in 38 minutes, not a full block, not a full 55 like we had. The other thing is, if any of you have any test modifications, you need to let me know. So if you don't finish, though, you don't finish, and there's not extra time, nor do we give passes, so you have to finish by the time that second bell rings. What we're going to have you do when you walk in, all of you the same, there's 28 of you in here, so it's going to be numbered 1 through 28. You're going to leave 1 through 28 phones up front. And if you have to go potty, you have to go beforehand. The reason being, we found out that there was a substantial number of people who were, somebody actually did this, which is kind of like what you find in prison. They had a friend leave them a formula sheet in the bathroom. So we can solve that just by saying, hey, if you have to go potty, you can go before, not during. So maybe we can even take a collective bathroom break together. Over across the hall would be great. Is that what you did in elementary school? You said bathroom time or no? Okay, at Catholic school we did. So we can take a bathroom break. We can walk over together, and I'll make sure we get our hands washed and things like that, because that's important as well. You're going to leave your phones, though, up front, and no bathroom breaks once the exam is started. You only have 55 minutes. If we've covered it, it's fair game. We're going to give general review, but again, some people don't feel as though that it's a carbon copy of this with different numbers, which is what some teachers do. Stuff you need to know is domain and range of all of your functions, one-to-one functions, what it means for it to be a one-to-one function. A one-to-one function is one where it has a vertical line test, a horizontal line test, or every input has a unique output. The outputs aren't reused. You need to know everything about equations of lines, parallel, perpendicular, given 2 points, vertical, horizontals. You need to know how to do composition of functions, which is when you insert one function or one variable into another function. You need to recognize when you're adding, subtracting, multiplying, and dividing functions. You need to know about piecewise functions and inverses and their properties. Now, I used to say go through and write this down. Apparently that's not a thing anymore. If you want to take your phone out to take a picture of it, you're more than welcome to. That apparently is a thing instead. Remember, it was kind of shocking. I think it was like 2 or 3 years ago. I was teaching this class. I was teaching pre-calc at U of R, and I said, now these are the type, and the room it was a lecture also, there were 120 kids. And I said, when you do this, make sure these are the things you get down. I go, now write these down. And literally every kid stood up and took their phone, and I thought there was like I maybe had something had happened to my face or something that I looked really awkward, but they were just taking pictures on the board. Whatever you need to do, that's the stuff that you need to make sure that you're aware of. Every single class that you've had so far, you can go through and find. If you missed for any reason, it could have been everything from getting a road test to a funeral in the family. You're expected to go back and rewatch. You can rehear from us or different sections. It doesn't matter. Questions on the structure and everything of the exam. We're not taking the test away from you at the halfway point. That's just to let you know this is the halfway point. If you take too long on one section, you may not have the same amount of time for the other section. Okay? All right, next thing up. Somebody had asked previously from that review sheet that I gave you all what the difference or what a continuous function was. Or sorry, what a discrete function was. There's 2 types of functions, and we talked about it. I think the example that we used was the one with the deer, where like you can't have like 12.2 deer. So a continuous function is one that every x gives an output. A discrete function is there's some criteria on it. It's easy to restrict it down to just being integers, things like the number of people in class. I can't go in and say, like, I have 12.4 people in class. Where is the 0.4? Does it look like did we cut you going up and down? Did it just on the side? It would be kind of awkward if, two legs walked in and there was nothing on top of it. That would probably be a really bad student, too. In any case, that's the difference. And where did we find this? In the first block, we literally put into Google, what is a continuous function in math, and clicked on the first one. Discrete function. Now, these are the ones we're going to go through and work on. We're not going to do all of them, and we'll show you where you can find more information or more help if you need it. Taking a look at what's there, though, let's start off with number 2. And looking at number 2, let's state our domain and range on this. So, Ben, take a look at 2. What's the domain in 2 going to be? What's that, the 0? Why a bracket? Perfect. And by the way, make sure they're definitively a bracket or a parentheses. Anna, what would you say that the range is on this? What y values do we use making this graph? Good. Every range value is used. The part that some of you struggle with is taking the calculator away because you know all the calculator gimmicks, but you're not. We're getting you ready to take the AP Calc exam, which has a calculator and calculator-free section as well. Understand, you should be able to answer 4 without the calculator. You all did. Raise your hand if you remember what an absolute value graph looks like. You can tell me what shape that has. Yeah, it looks like a V. What's the domain of an absolute value graph going to be? If you get stuck or don't remember, the domain is every input that gives an output. So, think about the inputs that are going to give an output. If I pick any number and plug it in, will it give me an output? Hands up, please, if you can tell me. With that in mind, if you think of the graph or think of just plugging in values, what would our domain in 4 be? Now, if you say that, let's say you said 3 to positive infinity, okay? I don't take issue with that, because as it said, he's right. What do you get when you plug in a 3? When you plug in a 3, what output value do you get? Nope. 3 plus 3 gives you 6, so that gives you an output. Is there more? Or is that the answer? Can you tell me why? And every number has a distance that it can go to 0. If I plug in negative a trillion is 1 trillion units away from 0. It takes whatever your argument is and makes it positive. Now think about the range or the output values. Every input gives you an output. What output values will we be getting? Who can tell me that? Think about, start plugging in some values. And I love that there's some of us just sit and stare and wait. That's not going to make you successful. Think your way through it. You're going to have some times where it gets screwed up. Think about the type of output values I'm going to be getting. Which are the y values? We got 1, 2 people that can tell me what our range would be. 3 of us. Y. When you go through, what's the smallest output value I can possibly get? 0. What x value causes that, by the way? If I plug in a negative 3, I get out a 0. What's the absolute value of 0? 0. Any other number, when I plug it in, what type of output value will I get? Something greater than 0 or positive. That's how you figure out your range. You have to engage your mind. It's not, there's adding, so I subtract. You have to engage fully. It's not tough, but you have to get over that initial hump. Questions on that? Let's take a look now, please, at question 5. I'm asking you about the domain. You don't get a calculator to answer something like this. Does every input give us an output? Or can you think of an output that won't give you, or an input that won't give you an output? Is it possible to have an input in question 5, that g of x, so when I plug that number in, I won't get an output? And if you can't come up with any, it's negative infinity to positive infinity, because everything would work. You've got 1, 2, 3 of you that can think your way through. You have to be analyzing. And if you're sitting there wondering how these people have their hands up, you pick numbers, start guessing, plugging them in. Would I get an output? I don't care what the output is, as long as I get it. We've got 1, 2, 3, 4, 5 of you that can tell me. What? Hands up, please, if you can tell me what happens when I plug in an input of 3. So we know x can't equal 3. Are we done? Negative 2 would give me 0 over something, a number, so negative 2 works. You can get 0 out. Negative 3 doesn't work either. Remember, here's your fractions. You can't have a 0 in the denominator. You can in the numerator. So I need to skip 3 and negative 3. Now think about that in terms of interval notation. As I go from left to right, what would my domain look like? Think about that. Everything works, but we need to jump over negative 3, then jump over positive 3. What's that going to look like in terms of an interval? We got one person that can tell me, 2, 3 of you. What do you want to say?
Negative infinity.
So,
Negative 3.
okay. Good.
And then you. 3.
That's not right. Because we're missing something. Who sees what we're missing? There's valid domain values that we currently don't have listed. What do you want to say? You're saying right here?
Yeah.
No.
When you go from negative 3.
We need to include another wedge in here. What does this signify? This means it's everything except when I go from here to here, what did I just do? Hands up, please, if you can tell me what that notation means I just did. The negative 3 isn't a valid input. I jumped over it. What did I do over here? What value did I jump over?
3.
Questions on that one? All right. Let's take a look, please, at the next one. And again, you have to be able to analyze this. Take a look, please, at question number 6. Think about the domain in 6. We talked before. It's up there on the board. What you have to be concerned with in terms of domain. Who can give me a number that is not in the domain in question 6? What's a number that when I plug it in, I won't get an output value? Something in there falls apart. Then give me any number. 3? All right, plug in a 3. What do you get? What's in the numerator?
5.
What's in the denominator? Okay, does 3 work? No. So is 3 in the 3 in the domain? No. Okay. Now let's try other numbers. So we know 3 is not in the domain. What do you want to say? 0. Plug a 0 in. Does 0 work? Is it in the domain? Why not? In the radicand, yep. So we know 3 doesn't work. We know 0 doesn't work. Who's got more numbers? Again, if you don't know, it's not magic. You try numbers. You literally pluck numbers out and say, now probably you're not going to try 45,000. But what's another number? 2. Does 2 work? Why not? Where? Negative radicand. So 2 doesn't work. Negative 4. Does negative 4 work? No. Negative radicand. Now, give me different numbers. You guys are giving me all numbers that don't work. What? Does that work? No. What are some other numbers? There's a lot of numbers that have one losing. 4. Does 4 work? Okay. So we've said all of those numbers that we listed out before. You're the first one to give me a number that works. Who can give me another number that works? Again, these aren't mysteries. You have to try. You all are lacking intellectual perseverance. Yes? 10, does it work? Okay? It's not pretty, is it? Because you've got what in the denominator? Root 7. Yeah. Terrific. What? What would your domain be? Give me that as an interval. You're absolutely right. You just said it. Any number bigger than 3. So what's that as an interval?
3.
There we go. And the very first one that we started with, Alexis, was that you who gave us the 3? She picked the critical value right in the beginning. Now, normally 3 would be in the domain of the function, except where does the 0 get spit out into? The denominator. You can't take the square root of 3, but it gets spit out. Take a look now. Here's my 2 questions on that. And again, notice, if you had the calculator, you would be like mindless droids and go through and just start plugging things in and go, I punch this into the calculator. Find interval is from 3 to infinity. You're smarter than that. Take a look at what's there for 7. That's my f and that's my g. What do I have to do to evaluate out g of f of negative 7? Nathan, what would you have to do for that?
If you multiply surfaces,
Nope. That would be the case if that was a closed dot. Who remembers what we have to do for this one? What do you want to say?
find f of negative 7.
All right. Now, again, I love this because you all fall to pieces. Hands up, please, when you can tell me f of negative 7. So don't go to the calculator. You're smarter than that. You're so much smarter than that. F of negative 7 value. Hands up, please. What? Okay. What do we do next, Abby? And this and the other group, they start going, well, I can't do that. I'll hold your hand through it if I need to. All right. Jessica R., what's 55 plus 8? 60, what did you say? I'm sorry. 60, 65? What did I say? Oh, sorry. I'm sorry, I was thinking of another one today. You're right, 63 over, what's in the denominator? 50. There we go. That's it. Is that difficult? I need a calculator. Take a look at the next one. You've got h of x and m of x. First thing up, you're taking h of m of x. This notation and this notation mean the same thing. H with an open circle of m of x. You're taking the functions and plugging one function into the other, or replacing the x's in the outside function with parentheses and inserting the other one inside of it. So, John Paul, which function is getting inserted into which in A? Is the h going into m, or is m going into h? We work from the outside in. So if this is the case, here's my inside function. It needs to get out, so I plug this into that. So I go through and I write the h of x function, but everywhere that there's an x in the h of x, I'm going to not write an x, I'm going to write parentheses. So instead of being x minus 2 over 4, it's parentheses minus 2 over 4. And what gets inserted into those parentheses? Erica T? What did you say? I can't hear you. Which is? And this is another part, because then we say, well, can you do more? Yeah. Look at that numerator. What's the numerator going to be? What's 2x squared plus 4 minus 2? What's that? You have like terms. It's not like there's a 1, I mean, there is a 1 in front, you could distribute if you want it. Now, once I get there, you have to ask her, is there more that I can do? And this should jump out at you. What can we do at this point? I see 1, 2, 3, 4. What do I say? Yeah. You can reduce out a common multiple of 2. It's, by the way, here's another thing. It's only common if it's everywhere in the fraction. Some of you think that you can do parts of these and reduce out parts. Common means everyone has it. Like everyone right now, hopefully, has a pulse. And we're going to hope that you maintain that pulse throughout class as much as some of you may be sitting here wishing you were anywhere but here. You need to maintain your pulse. So everyone has that in common. I'll even say this. It's not common that all of you live in Webster. Is there anybody here who doesn't live in Webster? There's a lot of you. There's this whole, are you in Penfield? Or isn't there parts of, what's next? Is Wayne? There's parts of, no, Ontario. Is that what's out if you keep going? You like run into Ontario County? There's parts of Ontario County that come here. It's not even all common that you're in Monroe County, that you live in Monroe County. You can live in Ontario County. That's not common. It needs to be common. So when I go through, what can I reduce out from everything? Christina, what do you say? What's left? Questions on that? Now, we're going to go the other way. So we've got to take m of h of x, or m of h of x. Notice the circle is open and not closed. Both circles mean multiplication. So, Jaron C., what would you go through and have? Which one is going into which? So let's go through. What would you write out to make that happen?
2
And what's going in there? This is what I love. It always makes me, because again, you all fall to pieces. You have pretty much zero ability at algebra. And I don't even know, I would almost have rather have just gone over to Spry and traveled every day and just taught you this in 8th grade. Because we get to stuff like this. I don't know if we act as if some of you haven't seen fractions before. If I asked you to do this and I asked you to square it, I had people who told me this. Well, we know this, the outside's this, right? We still got a plus 4. We're going to square this. Do I just square the numerator? Do I just square the denominator? Do I square both? Which one? If I take the fraction and square, what do I have to do? All these different answers. Who's confident? No one. You've got to square the numerator and the denominator. Right away, you should be able to tell me what your denominator is going to be. Hands up, please, when you can tell me what you get when you square the denominators. 16. This is going to take a minute. You need to go through right now and take the quantity x minus 2 and square it. So somewhere on your paper, not in the middle of this, go to the side, write out x minus 2, quantity squared, and actually go through and square it. You're going to have to write it out twice, and Eli, let us know what you get when you take the quantity x minus 2 and square it. First order and last, or magic double distribute, I think is what Dr. Welcome calls it. Or you could go through and say the magic rectangle of fun. Let us know what you get as your final. What's that? Plus 4 at the end, because it's negative 2 times negative 2. But that's right. Now, the next thing that I'm going to do when I'm doing this, normally some people are like, well, I can distribute out the numerator. Sure, you can. It's not the most efficient thing, though. Who sees something we can do that's going to make our process become a lot easier as we go forward? We got 1, 2, 3 of you that see? That's it? What do you see that's there? Order of operations tells us we multiply before we add. Really? 2 people? See, this is the part that I mean, because this is Algebra 1 stuff. What do you want to say? Nope. If you're talking about here, because not 4 isn't common. This x squared doesn't have it. There's a reduction that you can do. It's staring you right in the face. What do you want to say? What's 2? You wouldn't ever say I ate 2/16 of a piece of pizza. Or of a pizza. What would you say you had? 1/8. So this becomes an 8. So now I've got this. I've got x squared minus 4x plus 4 all over 8. And then to that I need to add 4. Now 4 is a fraction in case you forgot. It's 4 over 1. Am I done now? No! You've got 2 fractions to add. You can tell me what they remember about adding fractions. Another thing. This is understand my frustration, because I sit here and go, you guys were deemed proficient in Algebra 2. You took it as an honors class. In order to add 2 fractions, what conditions do you even got? We have 1, 2, 3, 4, 5, you 6. Okay, what do you say?
The denominator is
Do I have the same denominators now? Can I make it happen? What, instead of writing 4 over 1, what would I rewrite?
32.
That's outstanding. Can I add those together now going across? Cassie? All over? Questions on that? There's nothing on there that you couldn't do. Let's go over and look at 9. Now before I do out 9, I look at the equation. We need to find the inverse of that. So what I'm going to do first is this. Hands up, please, if you can tell me what type of graph this is going to be. Because I see inverse, I start thinking about some stuff that I know because I'm really good.
Parabola.
Okay, what do we know about parabolas? Hands up, please, if you can tell me. Is it a function? Yes, it's not one-to-one though. And if it's not a one-to-one function, or the y values are arrived at more than once, what do we know about it? If it's not a one-to-one function, what do we know about this? Is the part where my heart starts going. 3, 4, 5 of it. Luke, you know? Careful, you gave me too much. The inverse won't be a function. The inverse won't be a function. Does that mean we can't find the inverse? And there's one, and I'm going to tell you right now, I'm going to warn you right now, and you'll still get it wrong. There's one of those questions. Let's say this is, when I clean the windows, I live next to the pools. When I clean the windows on my house, I always feel really bad because all that I hear for the next like 2 to 3 days is banging. Does everybody know why you hear bang? Does everybody have that happen when you clean the windows out in here? You just hear stuff that's like this all the time. What is that sound? What? You all are my little birds. This question, you all are my little birds. And I'm going to tell you now. So I'm warning you, I clean the windows. I don't want you. And then the worst part is there was one day, I look over, I take my little Rocky for a walk, right? And I heard the thing, and I didn't think much of it. I thought it was from the front of the house. I go and look. Thank God there wasn't anything there. I go to let the dog out, and birds are disgusting things anyway. So I go to let the dog out, and he's over in the corner like sniffing something and going like this with his nose. That bird, I almost had to get the dog away. I couldn't, so I had to take him inside. I think I poured like bleach on him, and then we just gave her a bath for like 3 straight days because birds carry tons of germs. Don't feed the birds here. Be on the lookout, please. I don't want you to swim into this, fly into this. As we do this, what's our first step in taking the inverse? Alexa, what do you say?
Well, you switch the X and the Y.
So what am I going to write out, please? What do I do next? Alex V?
Add 3 to both sides.
Next thing up, Alex M?
You divide the side.
What do you do next? Jared? So I would say y inverse is going to be equal to the square root of, are we good? Nope.
There should be a plus or minus sign in between.
When you take the square root, it's a plus or a minus. Keep this in mind. When it's y squared, I think we talked, didn't we say that the exponent tells you the number of answers the question's going to have? Like if I had this, when we solve Pauli equations, we have y to the fifth, y to the fourth, y squared equals 0 or something like that. How many answers will this have? What's the degree or highest exponent? How many answers will it have? And if you don't have 5, you need to look for them. How many answers should this equation have? Does this have 2 answers now? Absolutely. Let's see, take a look at 10. Take a look, please, at 10. Looking at what you've got, Will, what would you go through and do in 10? I've got that is my f of x, that's my g of x. I need to evaluate out f of g of -5. What would my first step be?
You do negative 2x minus 7 minus negative 4x plus 7.
No, that would be the case it was a closed dot in there. You've got to take the outside, plug it in here, start at your number, g of -5. What is the g of -5 value going to be? Hands up, please, if you can tell me. You don't need a calculator. You are very, very bright individuals. We got 1, 2, 3, 4 of you. 5. What do you want to say? 23. 23, all right. Who can tell me what I'm going to go through and do next? 3, 4 of you. 5. So now I need to evaluate out f of 23. Hands up, please, when you can tell me what f of 23 is going to be. 3 people. 4. No. -50, because we got to take, hang on. -2 times 23, is that right? -2 times 23 is going to give us -46, and then we need to subtract 7 more, so it's going to be -50. There you go. There's one earlier, too, where I got stuck, and I guess I got these answers transposed in my head. Questions on that? Now, and listen, I'm going to tell you the numbers on the test if they're very easy. Take a look at this next one. I'm going to actually answer a bunch of these questions before. I'm going to answer the question maybe out of order. Think about this, and we'll go. Let's try this to extend. Look, please, at number. Look, please, at number 11A. Look at 11A. I don't want you to go right to the calculator on that. For 11A, who can tell me, please, what about the domain on that? Who can tell me what our domain is going to be? Who can tell me what our domain is going to be? Think about where your problem areas are going to occur, what inputs give an output, and which ones don't. We've got 2 of you, 3. How? Give me, if you don't know, give me a number. -9. All right. I plug in a -9. What's -9 plus 8? -1. Is that in the domain? Why not? Perfect. All right, so we know -9 is a no-go. -8. What's -8 plus 8? Can you take the square root of 0? What is it? You sure? Then you multiply that by 5. What's 5 times 0? Okay, so you gave us -8. So -8 is in the domain, -9 isn't. Who can give me another number we're going to poke around with? And to build up our domain, we know -9 isn't, -8 is. Any numbers below -9. Who takes issue with that? You should be outraged and offended and ready to take off your shoes and throw it at me in anger. -8. -8 doesn't work. Which means, if the numbers below -8 don't work, what numbers do work? Let's try a number above -8, so let's try a number like 100. 100 plus 8 is 108. Can you take the square root of that? Multiply by 5, you're going to get something. So our domain is going to be this, and we'll show you with the calculator in a minute how you can look at it. Don't worry. We've got the domain here. What is our domain going to be? Well, it's going to be from -8 and up, and we said -8 was included. Now let's think about our range values. Thinking about the range values, let's think about the type of outputs you're going to get. You can tell me what kind of output or Y values you're going to get if you plug in, try to plug in a 1, plug in 100, plug in a -7. Every one of those outputs has something in common. Or what type of outputs, I guess, are we going to get? So what do you think your range is going to be? So you're going to say, let me see if I can shrink this down. So the range is going to be 0 to positive infinity, and I agree. What's at 0? Is a bracket or parentheses? Because we can't get 0 as an output. He gave us an 8 or a -8 and it worked. Now, go into your, let's answer this before we go into the calculus. Who can tell me what the domain of the inverse is going to be? Who can tell me, please, what the domain of the inverse is going to be? I did this before. Look at the original. I don't need to find the inverse. You should be able to tell me what the domain of the inverse is going to be. No. Take a look at what's there. What's the domain on the inverse going to be?
Isn't it the same as the range?
Is the same as the range of what?
The regular function, first function?
The original. Because what do you have to do? What happens to the inputs and the outputs and the inverse? We switch them. So our domain of the inverse is going to be 0 to positive infinity. Our range then would be what? Hands up, please, if you can tell me what our range would come out to be. 2 people, 3.
-8 to infinity.
Let's find out what our inverse is. So I'm going to say this is y equals 5 root of this. Robbie M., what would you do to find your inverse?
I would divide by 5.
Oh, no, you gotta switch off the X minus.
Now, what do? Divide by 5, x divided by 5 is equal to, and we're going to, again, you're going to hit it in just a second. We'll wait. Leah, what would you do next? No, it's already square root. How do you undo the square root?
Oh, you square.
Now again, over here this will be with x squared over 25 is equal to y plus 8. From here I go through and switch them. So my inverse is going to be x squared over 25 minus 8 is equal to, did we use function notation? Yeah, f prime or f inverse of x. Now, before I go on though, well, let's do this. Go into your calculators because we're going to re-examine this in just a second. I don't want you to think we're done. Go in please to your calculators. And what I want you to do is this. Plug in the original. So go in, make sure you've logged in if you haven't already. Let's go in and make a graph. So get a document going. So go to 1 for a new document. So please. Go in and go over to 1. Don't save what's there, even though you might want to. Let's go through and add a graph. So 2. And we're going to plug in the original, which was it 5 times the root of x plus 8 or minus 8? Okay, so plug that in, please. And hit enter. Now, I'm going to ask you this. We've got to have a little bit of analysis here. Looking at what's there, am I seeing enough of this graph? Let's start. I'd say no. Think about where the graph is. What do we need to see more of, and what do we need to see less of? Are we good going side to side? Is the x-axis good? Yeah, I can see where the graph starts. It's probably going out to the right. The problem is, can I see where it's going? The problem is with the y's. Do I need to see lower on this graph? Do I need to see higher on this graph? So let's go in, please, and press menu, window for 4. We're going to go to window settings. X's we said were terrific. Let's change our Y's. Do we need to go all the way down? Let's make our Y, change our Y meant to be -1. Now, here's another one. If you do it wrong, you just go through and change the numbers next time. Who can tell me how high they want to look at on this? All right, let's try 20. If it needs to be changed, we will. And hit OK. Do I see pretty much everything in there? Yeah, pretty good. Could you have done 25? Sure. Could you have done 100? Probably a bit too much. 25, I think, is the one that fits every bit of it in there. Now, looking at this, what's our domain? -8 to +8. So does that confirm or dispute what we stated before? Confirm. How about the range? That confirms our range. Now, I'm going to ask this. Our inverse, when I look at the equation that you have for inverse, what is the equation of the inverse? What type of graph is that going to be? It's a parabola. Does our graph need to be a parabola? Is the inverse of this half parabola going to be a full parabola? So what you need to do is this. What did we say the domain of the inverse was going to be again? The domain on this would be from 0 to positive infinity. Therefore, the reason being, if you give that y equals the x squared part, it gave us too much of an inverse. So, here's what the equation of the inverse is. It's that equation as long as you're working from 0 and up. Is the inverse going to be a function? I'd say yes. How do we know, by the way, without finding it, that the inverse would be a function? because it's what? It's 1 to 1. Yes, the reason why f of x is 1 to 1. We're going to do a quick review of linear stuff. Oh, let's look at 13, sorry. 13a. What is it asking you to do in 13a? Amanda? So what would I be multiplying together? So, first order and our last. Magic box, double distribute, I don't care. Hands up please when you can tell me what output value you would get if you took those two binomials and multiplied them together. We got 1, 2, we'll wait for 9, 3, 4, 5, 6, 7, 8. Hannah, what do you say? First order and last, that's what we should get. What is it asking you to do the functions in B? Hands up please if you can tell me that. Let's evaluate the function at 7, f of 7, and g of 7. What's f of 7's value? Hands up, please, if you can tell me what f of 7's value is going to be. What's g of 7's value? Hands up, please, if you can tell me what that's going to be. Come on, come on. 55. So I need to take 23 minus 55. What I have? Okay. Careful. Negative. Questions on that? Write an equation that goes through those points. What do I need to know in order for me to answer? By the way, these we're going to breeze through because this is Algebra 1 stuff. What do I need? Slope. How do I find it? So I take y2 minus y1 all over x2 minus x1. If that's the case, it would be -3 minus 1 all over -4 minus 5. What's the slope of this going to be? Noah, what do you say?
-4 over 9.
4 over 9. They're both negative, so that's why he said it was positive. And some of you are doing y equals mx plus b. We need to get beyond that. What is this? What would one possible equation? There's actually two that I would go through and easily take. What do we want to say? We got 3, 4. Maddie, what do you say? Who's got another answer?
5 minus 1 equals 4 over 9 to the quantity of x minus 5.
Either one of those works, or any subsequent point that's equivalent to it would work. Do I need you to get it in y equals? No. Y equals mx plus b only works at one point. One single point. That's it. It only works if you have the y-intercept. Some of you do this garbage research. I plugged it in and I solved for b and then I rewrote it. Stop. Please. 16, hands up please when you can tell me the answer for 16. Read what's there, we'll wait for 6 of us. What answer would we say for 16? I got 1, 2, 3, 4.
Y minus 1 equals 2 x multiplied by x plus 2.
How'd you know the slope? What if it was perpendicular? What would you have to do? Negative reciprocal slope. How about this one for 17? I'm very, very good, and I need to draw these out. Goes through the point 2, negative 3, so I go over 2, down 1, 2, 3, put a dot there. This is the point 2, negative 3. Now I need to give the equation of a horizontal line that passes through that. So, then, the horizontal lines go side to side or up and down? Okay? What kind of line is, what's the equation of that line going to be? No, slope is 0. No, yeah, equals. You switch the coordinates. This is just a y equals line. What is y always equal to at every point along that line? Now, if you go in to Google Classroom, you're going to see all of the answers to this, including a fresh packet if you want to go through and give it another go, are available to you to do. So you're going to have a bunch of papers coming back. I apologize. If you ever want them back quicker, you can actually just take yours out of the bin if you want. Get those out. Get those out, please. You don't know who people are, it helps if you ask. And these guys out. And these out, please. I want you all to do so terrific on this test. It's disgusting. Make sure you study your stuff. Do your best.